Hey there, everybody. Recently, I revisited a book that I really enjoyed and it had some really awesome stuff in it. But today, I actually wanted to look at something that I thought was particularly cool about that book, and that was the binary system and how it relates to our number system. The book in question, by the way, is Code, Language to Solve. Actually, I think I have it. Boom. The book is right here. Code, Hidden Language of Software by Charles Petzold. And I cannot recommend it enough. If you really want to know more about like how a computer works, it takes you from everything through a flashlight and how it goes from that to a full-blown computer. I am still working through the book. I read it once. I'm going back through again, kind of re-chewing it. It is a lot to take in. He doesn't use a lot of analogies, but I'm going to try to break down a lot of stuff from this book because it's really fascinating and I would love to share what I've learned. But seriously, recommend this book if you haven't seen it. But the main thing I want to show you is how this can be 10, this can be 10, so can this, and even this. And all of this comes from the idea that we count in a decimal system. So humans have 10 fingers on their hands, so we typically started counting this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The counting system would be a little bit different if, say for instance, we were cartoon people, we only had 4 fingers on each hand. So we might count 1, 2, 3, 4, 5, 6, 7, 8. So that's the octal counting system, opposed to our decimal counting system. So right here is the decimal counting system. You'll see we have the number of ones placed, the number of tens, hundreds, thousands, and so on and so on. With that in mind, we count in the octal system like this. In the octal system, we count a little bit differently. It's going to be the number of 1s, 8s, 64s, and so on. Because we don't have, 9. So 8 is our 10 or our 1, 0 place. It's where we wrap back around. So let's say we were maybe a crab and we had, 1 pincher, 2 pincher, 3, 4. And we only had 4 little digits. We might count in base 4, which would be 1, 2, 3, 10. We move back around there. Then if we were maybe dolphins, we had flippers, it'd be 1, 10, 100, 101. And all this is because, we only have 2 spots, we wrap back around. There's no 2, there's 10 or 1, 0 when we move from the 1's place to the 2's place. So in base 2, this would be what we call binary. And in that case, if I were to count my dice, it would look like this. This would be 100 dice. This would be 101 dice. This would be 10 dice. And that's how you count a binary. So to test this, I'm going to go ahead and throw some dice up here, and I want you to tell me how many dice that is. So take a moment, feel free to pause if you want to. You can ignore the car moving in the background. Okay, if you're ready, this is 1,110 dice on this table. Though it may not look like that, that is how binary would count those out. So here's where it gets a little intense. If we were to count base 10 down to 9, down to 8, and all that, we kind of get how that works. But what do you do if you go from base 10 up to maybe base 16? So what I've drawn here is a sketch of my hands, just trace them out really quick. And humans would typically count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like normal. But if I add in a few fingers here, 3 fingers each hand, we're not 16 fingers. How would I count that out? What would we have counted like if we were all born with 16 fingers? We might count like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we don't go to 10 yet, because 10's 1 and 0. It's when we wrap back around. So what would we call these? Mystery fingers over here. Well, the accepted way to number this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, 10. And in reality, that could be whatever numbers we want it to be. But really, these aren't numbers yet. We don't have them, so A, B, C, D, E fills in that gap for us. This counting system is referred to as hexadecimal and would look like this, where you have, a 1's place, a 16's place, a 256 place. That's why when you buy a stick of RAM, it may be 8 gigabytes or 16, because these are more round numbers than hexadecimal, or why when you buy a new MacBook, it's going to be 256 gigabytes. Those numbers aren't round to us, but they are in the hexadecimal system. And overall, that's the basis of how to count in binary and how to think like a computer. Thanks for watching. If you like this sort of stuff, feel free to like, comment, and subscribe. This is the basics for how you can think like a computer, or, count in binary. It's the way that I've, read it and understood it, and I thought it was pretty cool. And this stuff helps me cement my understanding and can help me teach people if they think it's interesting. If you do like this stuff, feel free to follow along. I'll be posting things essentially from beginning this ground level to all the way up how a computer works is my goal. And other stuff between. I really like Dungeons and Dragons. I'll probably post content with that, basic rules and things like that. And if you have anything that you want to know, feel free to comment in there and I'll go take a peek at it. Appreciate you. Take care.